Okay, John Elson, Dr. Graham. We're here to work number 4 from the released FRQ from the AP Precalculus Exam 2025. Remember, we do this cold so that we can somewhat simulate the experience our students have where they open their test and immediately have to begin working. And we also want them to know that it's okay to make mistakes. I may make mistakes on here solving this problem. And if I do, I'd like for people to point it out and correct me in the comments. But it's important that students and teachers understand that kids can make mistakes, especially on a timed exam, and still get a good score. So I have not seen question 4. I'm going to get this focused where you can read this. Hopefully, it's not been very good focus. I'm not sure why I'm struggling to focus. We're going to try to give you, maybe I'll write a little bigger this time, so maybe you can see better than you did on number 3. We're going to go to the problem. There it is. All right, we have not seen it yet. Scrolling up. Here comes number 4. This one has the big long direction thing where we have to simplify and combine like terms, all that good stuff. So let's look at number 4, part A. We have functions g and h given by g of x equals 2 log base 3 of x and h of x equals 4 cosine squared x. Part 1 says solve g of x equals 4 for values of x in the domain of g. So we need g of x equals 4. The domain of g is all positive numbers because we can only have positive numbers inside the log. So that means 4 equals 2 log 3 of x. We're going to divide both sides by 2 and get 2 equals log base 3 of x. We're going to multiply or convert this to exponential form. 3 to the second equals x. So x equals 9. If we look back up here, if x equals 9, log base 3 of 9 is 2, times 2 is 4. It makes perfect sense. Okay. Then part 2 says to solve for h of x equals 3 in the interval from 0 to pi over 2. So we're going to say 3 equals 4 cosine squared x. We're going to divide by 4 and get 3/4 equals cosine squared x. We're going to take the square root of both sides, get plus or minus. Square root of 3 over 2 equals cosine x. And we know in the interval from 0 to pi over 2, there is no negative cosine. So it's only positive square root 3 over 2. That occurs at x equals pi over 6. That's part A. Check and see how well you can read that. Still blurry. I apologize for that. Not sure why it is blurring. Look past. If I can manually. A little better. Only the brightness though. I just want to focus. All right, we're going to write a little bigger on part B. How about that? Part B says 2 functions, j of x equals log base 2 of x plus 3 log base 2 of 2. And k of x equals 6 over tangent x times cosecant squared x minus 1. looks like. The x is inside the cosecant squared, but not the rest of it. Rewrite j of x, part 1. Rewrite j of x as a single logarithm with base 2 without negative exponents in any part of your expression. Your results could be in the form log base 2 of an expression with no exponents, no negative exponents. So we're going to take j of x, and we're going to say that's log base 2 of x plus log base 2 of 2 to the third power, which is also log base 2 of x plus log base 2 of 8. When we have two logs added same base, we can bring those together into one log and combine it by multiplication. Log base 2 of 8x. And that's in the form that we're looking for. So part 2 asks us to rewrite k of x as an expression in which tangent x appears exactly once and no other trigonometric functions are involved. So we have k of x equals 6 over tangent x times cosecant squared x minus 1. Yes, ma'am. That's right. And let's go to dessert. Take your food. Okay, thank you. Thank you, ma'am. That's all right. Bye-bye. Thank you. All right, cosecant squared x is I don't know why I'm drawing a blank here, but we're going to do this really quick. One reason I try to teach kids to derive these. So if I divide everything by cosine x, I get tangent squared x plus 1 equals 1 over cosine squared x is secant squared x. If I take the original Pythagorean identity and divide everything by sine squared x, I get 1 plus cotangent squared x equals 1. Nope, 1 over sine squared x, which is cosecant squared x. So cosecant squared x minus 1 is cotangent squared x. I don't know why I was drawing a blank there. 6 over tangent x times cotangent squared x. Cotangent squared x is 1 over tangent squared x. Which means that this is cancel one of these and one of these. 6 over 1 over tangent x. Multiply by the reciprocal, and you get 6 tangent x equals k of x. Tangent x appears exactly one time. Part C. Function m is given by e to the 2x minus e to the x minus 12. Find all input values in a domain of m that yield an output of 0. All right, we're going to use a little trick here that I like to teach called u substitution. I'm going to let u equal e to the x. That means u squared is e to the 2x. That means this is u squared minus u minus 12, which factors easily u minus 4 times u plus 3, which is e to the x minus 4 times e to the x plus 3. And we want to know when that equals 0. So we're going to set each factor equal to 0. And solve. E to the x equals 4, or e to the x equals negative 3, which we know cannot happen. This is impossible. And here, we'll solve for x by taking the ln on both sides and get x equals ln 4. And that would be all the input values in the domain of m that will yield an output value of 0. And that's question 4. Again, if you see anything that I've done incorrectly, this again, goodness gracious, I don't know why it's not focusing. That was better. Then that's so I can see all that from start to finish. Okay, get you want to look at it now. All right, if you see any errors, think I should have done something different, got tricks or anything, like suggestions in the comments. Thanks.